Now see a transistor as an amplifier. So we are going to discuss the working of the transistor as an amplifier but in common emitter mode. So we are using here the common emitter mode. Now see an amplifier is a device which is used to increase the amplitude of the alternating voltages or power or current. So let us see how does a transistor work as an amplifier. Basically whenever the transistor is used, that is used in actually here the in a active region, and in active region also the slope of the output voltage to the input voltage is negative, we can do in the previous graph. And because of this negative sign is actually showing here the input and output are out of phase. So let us understand the working of the transistor as an amplifier. Suppose there is a common emitter transistor and this side is here IE. Now there is a base resistance, that is RB. There is a biasing of this, and this is here the forward biasing, and that is done VBB. Here there is a resistance, that is RC, and its biasing is here with the reverse biasing with the positive terminal. This is VCC. Here we use a capacitor to get output, and here is output is here, that is VO. We can take is at here C2. Now we can connect one more capacitor here, that is C1, and that is here input voltage here. Now in this case we can write output voltage, that is V output is equal to VCE is equal to actually VCC minus ICRC. This is taken at here as here the output voltage. We have seen all these things in the previous cases, and we have done also IE is equal to IB plus IC, where IB has got very small value. Now let us understand working of the transistor as an amplifier. Suppose input signal I am taking from here, that is input signal I have taken like this here. This is the voltage we have taken, suppose Ri with the time. So this is alternating voltage is like this. Now first case, when output voltage or the input voltage is coming here as positive, I am redrawing the diagram like this here. So V and T. So when the input voltage is coming positive, so when this input is positive here, then this is already here the forward biasing with the positive. So this positive cycle, first half cycle of this alternating voltages, that is a positive half cycle, is supporting the forward biasing of the input junction. It means forward biasing of the input junction increases. As a result, IE increases. When IE increases, IC increases, because we know it IE is equal to IB plus IC. So when IE increases, IC increases, and when IC increases, output voltage, that is here VCC minus ICRC decreases. When output voltage is decreases and its reverse biasing is with the positive, it means output voltage becomes less positive. So we can show with the graph here the output voltage in this way, like this is here, it is the less positive. So here we have applied here the positive half cycle like this, but output we are getting like this is here. So we are taking here this side and this side, this is out of phase. Now suppose input signal is coming here as the negative half cycle. So forward biasing of the input junction is opposed. Because of that, IE decreases, as a result IC decreases. When IC decreases, output increases. Output decreases means here in this cases here, that will become more positive, and here we will be getting here this is in this way, that is a more positive. So here this is out of phase here, this and this also here. So we get here amplified amplitude here, or the amplitude of the input voltage, current or power increases here. So we can see here the different factors over here. We can take first the current gain, that we can write AC current gain, that is here the beta AC is equal to here delta IC, that is the change in collector current upon change in base current. Then we can also write here the voltage gain. Voltage gain is equal to output voltage divided by change in output voltage divided by change in input voltage. And from the previous graph or the graph in the transfer characteristics, we can see this is negative, that also shows the output is here the out of phase. And here we can also write voltage gain here, delta IC into RO divided by delta IB, that is change in base current, into RI. So, this is here beta AC into, this is called resistance gain. So, there is a voltage gain, current gain and resistance gain. We can also take here the power gain in this case. So, when we take here the power gain, we can write output power, power gain is equal to here output power divided by input power, that is here change in IC square into R naught divided by change in IB square into RI, and this we can write here beta AC, that is amplification factor, into here resistance gain. So, this is the different, this is the amplifier, it's working, and here now the different gains like the current gain, voltage gain and power gain.